Find the area that is bound by r equals root 3 over 2, so that's going to be a circle on the inside, and bound by r equals cos theta, which happens to be another circle, on the outside. Alright, let's draw a picture. I mean, they're telling us the inside and outside function, but I always recommend drawing a picture just to understand what's going on. Okay. So cos theta is a nice little circle, passes through the pole, as well as 1, 0 in either coordinate style. Okay. And r equals root 3 over 2, that's going to be a circle just a little less than 1 in radius, centered at the pole. Okay, so the area we're after is outside the big circle, but inside r equals cos theta. Okay. So I want this area, but where does it start and where does it stop? Well, where do these two curves intersect? Now, the nice thing about intersecting with r equals root 3 over 2, we really only have two things to check. Okay. When is cos theta actually equal to root 3 over 2? Or maybe we're plotting on the other side, but we're plotting negatives, so when is cos theta equal to negative root 3 over 2? Okay. Now, root 3 over 2 happens at pi by 6, as well as if you go all the way around, you can also get it at 11 pi by 6. Minus root 3 over 2 happens at 5 pi by 6 and 7 pi by 6. Okay. But it looks like I only have 2 points of intersection. Well, the cos curve goes back on itself by the time you hit pi. Okay? So what's happening is we intersect up here at pi by 6. Okay? And at pi by 2, we're at the pole, and now we're on this side, so we're plotting with negatives. Okay, so this happens, this intersection point is at 5 pi by 6. Okay. Then you go around again and you hit at 7 pi by 6 here, and then you go around again and 11 pi by 6. Okay. Now you don't just want to say, well, okay, we'll go from pi by 6 to 5 pi by 6, because then you're actually going to be working with this area here. So instead, what we should do is say, well, you also hit root 3 over 2 at things like negative pi by 6 and negative 11 pi by 6. Okay. And when we do that, it becomes really easy to see. We should integrate with our bounds of negative pi by 6 up to pi by 6. Just a nice, clean way to get this blue area here. So having worked out our bounds, and having drawn a picture so that we can very clearly see which one is the outer function and which one's the inner function. If not, we can just test a value like 0. Okay, the one curve is going to have an r value of root 3 over 2. The other curve is going to have cos at 0, which is 1. Okay, 2 is root 4, so it's bigger than root 3. And we can easily see the cos theta is the outside curve. Okay, so 1/2 outer function minus 1/2 inner function. Okay, and we're ready to integrate. So pull out the 1/2. Okay. We're going to transform the cos squared theta into 1 plus cos 2 theta all over 2. And then we're going to square, so we'll get 3 over 4 d theta. Now I can take the 1/2 here and subtract off 3/4 and get minus 1/4. Okay. Now, well, we could take out a factor of 1/2. But then I think it's time for us to get some antiderivatives. Okay. So the area is going to be 1/4 antiderivative of cos 2 theta is going to be sine 2 theta over 2. Then antiderivative of 1/2 would look something like theta over 2. Okay, so we're going to have sine 2 pi by 6, that's sine pi by 3, minus sine negative pi by 3. Okay, and plug everything in. Sine pi by 3 is root 3 over 2. Okay, so we'll get 2 root 3 over 2's on top. All over 2. Plus, and some 2's will cancel out. Pi by 6. Some more 2's will cancel out. And we'll get root 3 over 8 plus pi by 24 when all is said and done. All right, and so that is this nice blue area here.